Hello everybody, welcome to our special session on Lorenz curve and Gini index. I will explain what the Lorenz curve is, how to construct it for few, say 3, 4, 5, 10 or 20 persons, and how to get the Gini index from this Lorenz curve in two ways, graphically and also algebraically. I will not cover the case of many people, starting with income distribution functions. This stuff is one of my favorite topics, mathematically quite fascinating, but more complex and requires calculus, so maybe another time. Please meet family Lorenz. On the left is little Ann, then we have Bob and Cindy, and on the right Doug. Or in short, A, B, C, D. As you can see, they have different heights. It is A equals 2 feet for Ann, B equals 4 feet for Bob, C equals 6 feet for Cindy, and D equals 7 feet for Doug. As you can see, height is rather unequally distributed in this family. We want to measure this inequality. We start by ordering the persons from short to large, as has been done already. To get the Lorenz curve, we first add all quantities in question. Usually the quantities considered are money, income or wealth, but in our example it is height, and the total height of the whole population of the family is 2 plus 4 plus 6 plus 7, which is equal to 19 feet. Now, L of x expresses a part of the total quantity belonging to the poorest or shortest part x. N's height is 2 feet, which is 2 over 19 of the total height. And n is the shortest quarter of the population. So L of 1/4 equals 2 over 19. In other words, the shortest quarter of the population owns 11% of the total height. Next, the sum of the heights of the shortest half, N and Bob, is 2 plus 4 over 19, which is 6 over 19 of the total height. So L of 1/2 equals 6 over 19, and the shortest 50% own 32% of the total height. The sum of the heights of N, Bob and Cindy is 2 plus 4 plus 6 equals 12. Therefore, the shortest 3/4, 75% of the population, own 2 plus 4 plus 6 over 19, which is 12 over 19 of the total height, and we get L of 3 over 4 equals 12 over 19. Of course, the shortest 0% own 0% of the total height, so L of 0 equals 0, and the shortest 100%, the whole family, own 100% of the total height, so L of 1 equals 1. This is always true. To get the Lorenz curve or Lorenz function from these few values in the table, we draw these 5 points in the unit square coordinate system and connect them by straight lines. So this blue curve here is called the Lorenz curve. In general, if A is less or equal B, is less or equal C, is less or equal D, are the quantities or heights of the four persons, then using the abbreviation S equals A plus B plus C plus D for the total amount of the quantity considered, we have f of 1/4 equals A over S, f of 1/2 equals A plus B over S, f of 3/4 equals A plus B plus C over S, and of course f of 0 equals 0, and f of 1 equals A plus B plus C plus D over S, which is equal to 1 as usual. As before, we connect these 5 points by straight lines to get the Lorenz curve. Note that all the points x, L of x must be on or below the diagonal, since it is impossible that the sum of the heights of the shortest quarter is larger than a quarter of the total, and so on. Only if all four persons would have the same height, these points would sit on the diagonal. The more they are below the diagonal, the more unequal the distribution is. Note also that the lower these 3 inner points sit, the larger the yellow shaded area is. In fact, the Gini index is defined as twice the area of the yellow shape. This Gini index is supposed to measure the inequality of the distribution. The closer it is to 0, the more equal it is. The closer it is to 1, the more unequal. Let us calculate the area of the yellow shape. Since we know that the area below the diagonal in a unit square is 1/2, all we need to find out are the areas of the 4 colored shapes below. They are 1 triangle and 3 trapezoids. Recall that the area of a triangle is 1/2 times base length times height, and for the trapezoid it is base length times average height of left and right side, and this average height is 1/2 of the sum of left and right side. In our case, all bases equal 1/4. Therefore the area of the triangle is 1/4 times 1/2 times a over s. The next shape is a trapezoid with base of 1/4 and heights of the left and right sides of a over s and a plus b over s. Therefore the area equals 1/4 times 1/2 times a over s plus a plus b over s. In the same way, the area of the next trapezoid is 1/4 times 1/2 times a plus b over s plus a plus b plus c over s, and the area of the last trapezoid is 1/4 plus 1/2 plus a plus b plus c over s plus 1. Therefore the area of the yellow shape equals 1/2 with the 4 area shapes subtracted. So we get this formula here. And with a little algebra we get minus 3a minus b plus c plus 3d, all divided by 8 times a plus b plus c plus d for the area of the yellow shape. Therefore the Gini index equals twice this area, so it is g equals 2 times this area, which is minus 3a minus b plus c plus 3d divided by 4 times a plus b plus c plus d. For our example, a equals 2, b equals 4, c equals 6, d equals 7, we get a Gini index of g equals negative 3 times 2 minus 4 plus 6 plus 3 times 7 divided by 4 times 19, which is equal to 17 over 76, which is about 0.22. This is a very low Gini index. The income of no country in the world, not even Denmark, is as equally distributed as height is in this family. For other number of persons we get similar formulas. For instance, for 3 persons with quantities a less or equal b less or equal c, we get Gini index equals negative 2a plus 2c divided by 3 times a plus b plus c. And for 5 persons with quantities a less or equal b less or equal c less or equal d less or equal e, we get Gini index equals negative 4a minus 2b plus 2d plus 4e divided by 5 times a plus b plus c plus d plus e. There's another way of describing and calculating the Gini index that doesn't use a Lorenz curve. For this, we look at all the differences between our 4 family members. The difference between Bob's and Anne's height is b minus a, the difference between Cindy's and Anne's height is c minus a, the difference between Doug's and Anne's height is d minus a, the difference between Bob's height and the height of his parents are c minus b and d minus b, and finally the difference between Cindy's and Doug's heights is d minus c. The average of these 6 differences can be written this way and can be simplified, so what we get is negative 3a minus b plus c plus 3d divided by 6. Now the relative average difference, the quotient of this average difference, and the average height, a plus b plus c plus d over 4 of the members of our family, is 4 times negative 3a minus b plus c plus 3d divided by 6 times a plus b plus c plus d, which is just 8/3 times Gini index. So the Gini index is proportional to the relative average height difference, and such a proportionality with different factors of proportionality is true also for all other numbers of persons. A related but slightly different concept is expected distance. We choose randomly a person and then we randomly select a person again. It is possible to select the same person in both rounds, but selecting Anne and Anne has a probability of 1 over 16, but selecting Anne and Bob can be done in 2 ways, Anne first, then Bob, or Bob first and then Anne, and has therefore the probability of 1 over 8. Then we take the absolute value of the differences. It turns out that the Gini index is always twice this relative expected distance. for every number of persons. What happens when children grow? From the formula g equals negative 3a minus b plus c plus 3d divided by 4 times a plus b plus c plus d, it is easy to see that if a or b increases, then the numerator of the fraction decreases while the denominator increases. This means the Gini index decreases, we get more equality. While growth of duck always increases the Gini index, for growth of Cindy it depends. If Cindy grows, say 0.1 feet, then the numerator increases by 0.1 and the denominator increases by 0.4. Then the Gini index increases if it is below 0.25, like in our example, but decreases otherwise. If all persons grow uniformly, the numerator of the Gini index formula stays constant, while the denominator increases, we get a smaller Gini index and more equality. Let me close by mentioning that the Gini index is named after the Italian statistician Corrado Gini, who developed the concept around 1912, and that the Lorenz curve is named after the American economist Max O. Lorenz, who defined the curve around 1905. Thanks for listening.